So you understand what is this r theta phi now? Okay. So we carry on. So Ix can by coordinate transformation Ix can be Iy equal to phi sin phi plus I phi plus phi Iz equal to. On the other hand, the radiated field is usually determined by spherical coordinates. Okay, what you have seen. So the relationship between the Cartesian and the spherical coordinates are often given by AR equal to sin theta cos phi plus A theta cos theta of phi A phi sin phi J equal to AR sin theta sin phi plus A theta cos theta sin phi plus A phi cos phi equal to AR cos theta minus A theta. Okay. So this is simply a coordinate transformation between the spherical and the Cartesian coordinates. So IE, that is equal to A theta I phi cos theta sin phi minus. R equal to. Okay, I think there's no point. Now let us come back to the main values. If I just go on doing it, you will be understanding like this. And let me give you the final expressions. H phi, I think that will be 0 for a small group vector. After you finish derivation is in Balanis, you can go through it. If you have any problem, you can ask me, okay? Because this way, if I just go on doing the derivation, just doing it for the sake of doing it, will be not beneficial for you. HR equal to. If you are really interested, you can go through Balanis. If you have any doubt, you can come back to me. I think that's the best way to tackle this. This is for any field, okay? This is not the for the far field. This is for the general expressions. This is H and E theta equal to ER equal to 0 and E phi is given by eta A square 4R I0 sin theta 1 by 1 plus GPR to the power of. Okay. So for far fields, how will the expression look like? How will the expression look like for the far field? For the far field case, will this be there? Do we have this in the far field? Just look at this one. Will we have this HR in the far field? No, because it has a 1 by R square. Okay, this will go off. What about H theta? What about H theta? What about H theta? Very good. The first term will be there. Absolutely right. Okay. And what about E phi? Also the first term will be there. Of course, e to the power minus JKR. Agreed? Now, do these expressions look familiar? Do these expressions look familiar to you? Have you seen this similar, not exactly same, of course. Have you seen similar expressions anywhere else? Yeah, where? Where? Half dipole, exactly. They are very similar to the infinitesimal dipole antennas, right? Only thing is that now for the dipole there was E theta and H phi. Here it is the opposite. We have E phi and H theta. Can anyone tell me the directivity of this antenna? What will be the directivity of this? What will be the directivity of this antenna? It has a sin theta pattern, so what will be the directivity? Pankaj, please mute your microphone. What will be the directivity of this antenna? It has a sin theta pattern. What was the directivity of a Hertzian dipole? We have derived it. Exactly. Exactly. 1.5. So this will also have the same directivity 1.5 because it also has a sin theta pattern. Right? Okay. What is RR? Radiation resistance. Just trying to find this out. This will be a W was half of real part of E into H star. Okay. So if we find put the values of E and H star, at the far field we get this equal to eta k to the power of 4 32 I0 square sin square theta by r square 1 plus jk, sorry, j is r cube. Okay. The radiated power P rad, that will be integrated over a sphere W ds, that will be eta k to the power of 4 32 I naught square 2 pi 0 0 to pi 1 jk r cube sin cube theta d theta d phi. So P equal to theta pi by 12 e to the power of 4 I naught square 1 g by pr. The real part which contributes to the radiated power, that is equal to P that, that is equal to theta pi by 12 e to the power of 4 I naught square, that is equal to half I naught square r rad. Is the definition of Lagrange releases we have seen, right? So this will be r rad, that is equal to theta pi by 6 e to the power of 4. Okay, or equal to theta by 2 pi by 3 k is by lambda square, where s equal to This is for single turn. For n turn loop, R equal to eta pi by 3 is by lambda square. So just keep the formulas in mind. The derivation is not important. Last step. Which step? But tell me. This one. P rad equal to this. That is equal to R rad. So the R rad will be this one. Yes. P rad you can calculate. Okay. That is equal to half I0 R rad square. That is how to be different design. Okay. So this comes from here. Okay. K square, by the way. Eta pi by 6 k to the power of 4. Eta is same, so I am not writing it. Pi by 6 k to the power of 4. It is pi by 6 k to the power of 4, k to the power of 4. Okay. So that is pi square a to the power of 4, 6 pi a to the power of 4. This is equal to a square. So e to the power of 4, a square, 6 pi. Now what to do? This is the what we have done. We have made it 2 pi by 3 into this Ks by lambda. Okay. That is Ks square. K square. What is the what? Ks by lambda square into K square lambda square. Now tell me what is D? Directivity was 4 pi K by lambda square, right? So 3 by 2, that will be 4 pi d by 2. So lambda square is there. Square is So you try to put it here, you will get the answer. Something like this. K square is there. This to the power of 4. K square is okay. What is K? K is 2 pi by lambda. Right? So this will be 4 pi square by lambda square. And this is lambda square by 6 lambda. So see, uh, lambda square gets cancelled. Lambda gets pi gets cancelled. So only 2 by 3 pi is remaining. Okay? That is how it is coming. Okay? Here, K square by 6 pi, right? What is K? 2 pi by lambda square. You put, you will get the answer. Okay? That is how it is coming. Okay, any other question? I went to the tough area, it was transformation was very easy. Anything else? Can solve a problem? Let me. Yes, that's a good question. If I have time, the horn antenna is very difficult to cover in one sense. The horn antenna, I will try my best. If I get time, I will definitely try because horn antenna is important. Okay, acha. So, what was RR? RR was eta by 2 pi by 3 Ks lambda square into n square. Okay, the question is find the radiation resistance of a one single turn দুই 8 turn loop antenna. This type of questions you can expect in the exam, okay? Not the derivations. Radius is lambda by 25 and eta equal to eta naught. These two things are given. How to solve it? Just put the values. What will be the answer? Just use the calculator. So for in the exam, this type of problems will come, not the derivation. So if you don't do the derivation, no problem. Just keep the finite expression in your book. The exam you will get this type of questions. What is the answer? Uh, Yes, very good. And for 8 turns, just multiply it with e square. Very good. It's close to 50 ohm, right? Very good. That's that. Okay, last problem of the day. After that, you can go to your lab. We will meet again on Monday. Okay, next Monday. Radius, radius of a small loop antenna is lambda by 25. Compare its physical and effective apertures. Okay. How to calculate the physical aperture? How to calculate the physical aperture? How to calculate the physical aperture of the antenna? It is pi s square. The area, the physical area, S physical equal to pi s square, right? So that is pi lambda square by 625. What is pi by 625? Pi is 0.005. Okay. So this is the physical aperture. Physical aperture is simply the physical area. What will be the effective aperture? How to find out the effective aperture? We use d equal to 4 pi ae by lambda square. This formula, right? What is d? D is 3 by 2. We have seen for the small loop. So what will be ae? Ae will be 3 by 2 into lambda square by 4 pi, or 3 lambda square by 8 pi. So this will be 3 divided by 8 into 3.142 is equal to 0 point, sorry, Shreya, sorry, what did you say? 119 lambda square. Okay. So what is the ratio of them? Ratio is AE by AP equal to 0.119 lambda square by 0.005 lambda square, that is almost equal to 23.66. Okay. Any questions regarding this? Sorry. Okay. So for loop antenna, practice this type of problems. Only this will come. Do not need to waste your time by going through big derivations. No point. Just practice this type of problems. Calculate the resistance resistance. Calculate the physical aperture. Maybe calculate the directivity. Okay. So practice this type of things. Only this type of things will come in the exam, not the derivations. It will be very difficult for you. Okay then. Any other question? Anything else? Okay, thank you. So we meet again on Monday.